We're looking at a typical screen from one of the batch lines, and this particular one is a Pompano line for Oldcastle. They're all very similar. You're going to have your products in your silos from your aggregates and your cements, and you have 3 weigh scales in this particular one, which makes it very efficient because you can only weigh one ingredient at a time. Then you zero out the scale in the automation after that ingredient is in, and then the next ingredient starts feeding. So you can imagine if you only had one weigh hopper, which some of the facilities do, it takes a little bit longer for all the material to get into that weigh hopper, where you can have a material from any one of these 5, which is also shown over here, and I will describe all this, or material from any of these 4 running at the same time, and then the rock scale. And once the weigh hopper is full of all the ingredients necessary, it runs into the mixer, provided the mixer is available and empty. So each one of your silos, in this case, it shows the amount of material in feet that's in the silo. It shows what product is in the silo, and that also reflects over here. You have SEM 1, SEM 1-5, Portland. And these names are all entered in your, when you're doing the manager page, where you can actually change it from here too, what product is in each one of these. So the batch is actually recipe driven, and your recipes are entered in by supervisors. They don't even have to be on this screen. This is typically your plant floor screen. On the drop down here, you can select all your recipes from the database. Now what the recipe has, it has not only what ingredients go into the mixture, but it also has the weight. So when you enter the recipe, these target weights here will be filled in. As you can see, this particular recipe, it's asking for 634 pounds of mason, and that's coming out of this silo here. And it's also asking for 158 pounds of fly ash, and that would be coming from this silo here. And it is also asking for 2,808 pounds of masonry sand, okay, and that's coming from this one right here. So what happens is, in the recipe, it also has the high and low values for your difference, which is the scale of where you want the weight to be within, the limits where you want the weight to be within. If it's out of limits, it will pause and let you know, and therefore you can pause the system, and you can manually add more weights from the other products to make it equal, so you don't have to ruin the batch. And then there is also the total weight that's in the recipe, so it wants to see what the comparison is. And all of this data is recorded in your database for each batch. So the way the batch works is, we'll go ahead and show you that right now. We've got a screen over here that allows you to start the batch, tell it that it's the last batch, because you can select how many batches to run, and then after the batch is run, you can reset it. But this one, you're actually asking for 100 batches, and this will light up when it's running the last batch, and it'll stop after that. Or if you don't want to go to 100, you can say last batch, and the one that's currently running will be the last batch. Also, anytime during the operation while it's running in automatic, you can pause the entire system. And what pause means here is that it will finish whatever ingredient is being added, or if the mixer is emptying, for example, when you pause it, it will finish emptying. Or if an ingredient is being added, but it hadn't finished all the ingredients, it'll pause, waiting for the next ingredient till you hit resume. This area right here shows you actually what is going on. So right now, this is a video, and I have started the video. I recorded the video, logged in remotely to Pompano, and when I started this video, it's actually in the process of emptying. So it has material in the weigh hoppers, as you can see. Hopper contains material. So there is material, and this material is waiting for the mixer to become available. So it tells that. So it's not going to dump into, and you can see the valves here are closed. It has already zeroed out the scales, but it's just waiting to dump the material into the mixer. So that's when this starts. So we'll start this video, and you can see the you'll see the high level. So now the mixer has emptied. So the mixer valve will close. Okay, waiting for mixer to become available. It is closed, and now look, these valves here have opened. And now you can see the weight is coming out because it's going negative. So it's dropping into the mixer. And as soon as that weight comes out, that material comes out, and it verifies that it's completely out because it knows how much material is in here, and the system knows how much material is in here. So it'll compare that to the negative value, and it'll say, okay, that hopper is empty. So it will zero it. It'll set your mix time. You can see once it zeroes, it closes these. Now it begins bringing in more material. You can see it is bringing in material from this screw is running, filling this way hopper, and meanwhile this valve is open, filling this aggregate to get to the weights that you have over here. See the weights? These are actuals. So you want that to keep on running. The masonry will keep on running until that gets to 634. The same with your mason sand. So that keeps on running. Now what it's doing now, it actually pauses. It's called dribble mode. So let me pause this and describe dribble mode. Your plants have different types of valves. Some of them, the valves are gate valves. Some might be slide gates. Some might be bladder valves. And then others might be clamshell valves. Now your clamshell valves, and we're just showing these all as valves, and when they're green, they're open, so you know material's dropping in here. You know that material's dropping through this valve into this screw, and you saw that screw running, and you'll see the weights going up, and notice it's only running one ingredient at a time. So it will need to add the fly ash, as you can see here. Fly ash is 0, it hadn't added that. After this mason sand, because it's coming into the same way hopper, after this is full to 2,808 pounds, these valves will close, and then the scale will automatically 0, and then it will feed in, this valve will open, that screw will come on. For the fly ash, it'll feed in 158 pounds of fly ash. All right, so once the fly ash and the mason sand are in this hopper, and once the necessary masonry is in this hopper, it will dump, these valves will open into the mixer. But now if there's material in the mixer, which it still remembers, it's waiting for this high level here to go away, the mixer will then empty into the valve packer, and then this will close and these will open and drop material in there. And it'll keep on doing that process. Going back to your valves, you have different ways of feeding material from your silos into your weigh hoppers. Some have screws because your silo's far away from the weigh hopper, so you have to bring the screw on. So you can see when it's green, it's running, the valves are open. In some cases where a valve does not have a screw, where it drops right in, those valves, when it gets near the weight, and this is done in the manager screen, say the total weight of this material that it's asking for is 2808. When it gets to about 2,700 pounds, instead of dropping in real fast, it pauses the valves. So it opens and closes, it jogs the valves, and it does the same with the screws. In some case, the screws, we control the speed and we will slow it down when it gets near the weight, the target weight. Now, in some cases, if they're just across the line starters, we just jog the motor as it gets closer to the weight so that we don't overshoot the weight. So we do the same with the valves, whether it's a slide gate, whether it's it might be a clamshell valve that has a dribble mode, and that's what we're talking about. Just before it gets to target weight, we always dribble the remainder of the material so that we don't overshoot. So it's a slower feed at that moment. We're either pulsing a valve or we're jogging a starter. So that's the way we don't overshoot. Now, our target weights that are set here, for example, this masonry is 634 is a target weight, okay? That is coming out of this silo. All right, notice it has a preact that an operator connector right here, that preact is 10. Okay, so it will take 10 pounds off of that 634. So at 624, it will start, it will close, it will shut off. And that'll be even after the dribble mode. So once it goes into dribble mode, probably around 600 pounds, it goes into dribble mode, and then at 624 it stops because there's always material that falls in. And the preact is saying there's about 10 pounds of material that falls in after we tell it to stop. And that's consistent. However, in our code, we do look at that preact and we see how far were we off from that 10 pounds, in the last 5 times we've dumped, and we average it, and then we automatically change the preact. So the operator only has to give it a starting point, so that sort of absorbs the mechanical deficiency after stopping the gate or stopping the motor or stopping the screw. That material will consistently fall in another 10 pounds or whatever the preact is. So that describes the preacts. So let's continue starting this again. We're still waiting for the masonry over here to reach its weight, and we're waiting for the fly ash to come in. Right now the fly ash is coming in, all right, at 158. It's coming to get into 158, and you can see that it's running. You see the screws running. This material's done over here. Everything's off. This hopper's full. All right, so we're waiting for all 3 hoppers. We're not using this one here to finish. Now, waiting for waiting for the valve packer. The valve packer. So low level, and it's waiting for the packer, the hopper level to go low, which means waiting for the mixer to become available over here. So the mixer is not going to open up until this is not high anymore, and then it'll drop the material out of the mixer. It tells you mixer contains material from the last batch. So it stays efficient. It's always got material waiting behind it to drop in. And that's the way we do all of your plants. All right, a little more detail about the screen that the operator sees out on the plant floor, and anybody can shadow this, to see the same thing if you log into the server. We have one batching server that we've installed at each one of the facilities that handles multiple lines if the facility has multiple lines, including the dryers, including you might have whey pods, and then your line controls. So there's a menu drop down seen up here. And when you select that, it gives a drop down, allows you to select other screens that you can go to. This area, white area up here, is for any alarms that would happen. And the alarms are all being recorded. And when an alarm does happen, for example, if something is overweight, or if a valve doesn't close, because we have confirmation on most all these valves. So if we tell it to close and we see it doesn't, we give an alarm. If a motor overload trips, multiple alarms in each system. So you have this area over here that shows the operator what's actually going on, and then this area up here that would show any alarms. And the alarm, you can acknowledge the alarms and clear them this way. The other thing is, notice each one of these motors and valves, and even your vibrators, that's what the V stands for. They all have, like these say closed, they all have pop-ups. So the fact that I'm not running live right now, I can't click on this, but if you click on any one of these motors or valves with the mouse or the touch screen, if you're in the plant floor, it brings a pop-up up, and it launches a pop-up, not large, about this big, and it allows you to select, if it's a valve, it allows you to put it in open mode, auto mode, or close mode. If it's a motor, it allows you to put it in auto, off, or run. Run would be manual that you're telling it, but most everything that you're going to be using is going to be in auto. That means that the code in the PLC is controlling, that valve, the code in the PLC. If you have a valve in the closed mode, the PLC will not call that to come on. Well, that's not necessary for these. may have these closed because these ingredients aren't being used. So that's operator selectable, but you want everything in the auto mode. Like this valve here is auto. This is the valve that we pulse and open, in the code to put weight in from this silo here. In some cases, we have a valve and a motor. So the PLC controls if it's an auto, and you control it from the screen. If you either make it off or if you make it on, you force it to be on. That's normally used for maintenance mode. Or if you have to pause and add an ingredient, for example, this didn't go in well, say that this was one of the ingredients that was necessary. So you would put this in manual open, you'd launch this pop-up, and you would, run this motor until, while you're watching the weight, and then you'd shut this motor off and then shut this off. So now you've added in manually the weight, and then you can hit resume, continue if you had to pause because something didn't work, because something physically in the field jammed, you got a rock in a gate or something like that. So those features are that way. This dust collector in this particular plant, it has a start and stop. It's just a manual from the operator, start and stop. Many of the plants, the dust collector actually comes on when the process starts running. So there is a variation from plant to plant. This is not the White Marsh plant. It is Pompano line. White Marsh is not running right now, so I wanted to be able to give you guys something that you could see. And down here you can have your selection. These are all buttons, valve packer only, or you can have bulk bag only. So that gives the selection as to where the mixer is dropping its material, either into the valve packer or the bulk bag. Very simple process, but it's complicated what's going on in the background for all the checks and balances that we have to make sure that nothing overflows or that nothing jams, and we give warnings when it does. So it's a real nice process, and it's very typical of all of the plants that you have.